Our next topic is solving problem using circuit analysis technique called nodal analysis. Nodal analysis is based on Kirchhoff's current law, KCL. So here you have given a problem with 2 current sources and 3 resistors. So you can see only current sources in the circuit and 10 resistors. So, and the question is to calculate unknown voltages across various symbol elements. 3 elements are here. One is 2 ohm resistor, so you have to get the voltage at this position with respect to ground. Across 1 ohm you have to get the voltage at this point with respect to ground. And across 5 ohm means that is a voltage difference between this potential and this potential. So if you want to calculate this unknown voltages, given only current sources, it is better to use nodal analysis technique. So in this problem, you can solve easily by using nodal analysis. So now for doing nodal analysis, first of all we have to check how many nodes are there. And what is a node? A node is a point where 2 or more branches meet. So a node is a point where 2 or more branches meet. Now you can see here, this is a point. Here the branch with the circuit element 5 ohm, the branch with the circuit element 2 ohm, the branch with the current source 3.1 ampere meets. So this is a node. 1, 2, 3 elements meet. Similarly, this is also a node. 1, 2, 3 elements meet. This is, we can say, as a ground node where all the elements are grounded. So it is with we'll normally say ground node as a 0 potential. So first you have to identify, for doing this problem, first you have to identify the number of nodes. If there are n nodes, that means you can have n minus 1 unknown voltages will be there, and there are, you can even write n minus 1 equations based on that for calculating those unknown voltages. For example, in this case, you have 1 node, 2 node, 3 node. You have 3 nodes. So you have 2 unknown voltages. As you have 3 nodes, that means n node, that means 3 node, you have n minus 1 unknown voltages, 2 unknown voltages are there. So you can write here 2 equations for getting those unknown voltages. And as I told you, the basis of nodal analysis is Kirchhoff's current law. So for doing this nodal analysis, I have listed out the following steps. So if you are going in the order that steps, you can, the nodal analysis we can solve easily. See here, step 1 for this circuit, identify the number of nodes. So you have to identify here how many number of nodes are there. So look here, this branch, this branch, this branch meeting to this common point. So this whole I can take as one node, same marking as node 1. Now this branch, this branch, this branch, all are meeting at the common point here. This can be assumed as a node. So I am treating it as node number 2. Now this is the bottom node where all the elements are connected or grounded together to this common node. This is the bottom node. I am marking as node 3. So our step 1 is finished now. Identify the number of nodes. There are 3 nodes are there. You have identified it. Now the next step is select bottom node as the reference node. Now see the node 3, that is the bottom node. Take it as the reference node. That means you are assuming the potential of that node to be 0. So all other, why we are calling it as a reference node? Because all the nodal voltage we are writing which is with respect to the reference node, which is assumed to be the 0 voltage. So now the 2 steps finished. Identified the number of nodes. There are 3 nodes. Select the bottom node as the reference node. So that is node 3 is the reference node. Now redraw the circuit for convenience, which means that we are doing here the nodal analysis. So the nodes should be more projected. So we draw the nodal diagram. So now we have to redraw the circuit for convenience, means you have to draw the node diagram. So the nodes will be more clear. So first node I will mark it as here. This is the node 1. Now second node, this is the node 2. Now node 3. This is the node 3. So I mark in the nodal diagram. Now I am drawing here the nodal diagram. The nodal diagram. So the 3 nodes, node 1, node 2 and node 3 I have drawn. Now look here, between node 1 and node 2 you have a 5 ohm resistor. So between node 1 and node 2 you have the 5 ohm resistor. Between node 1 and 3 you have 2 ohm. So between node 1 and node 3 you have 2 ohm. Now between node 2 and node 3 you have 1 ohm. Between node 2 and node 3 you have 1 ohm. Again between node 1 and node 3 you have one more element, that is the current source 3.1 ampere. So between node 1 and node 3 you have one more element, that is marked as the current source. So its arrow is upward direction, 3.1 ampere. So between node 1 and 3. Between node 2 and 3 you have another current source also. It is marked down arrow with, so the direction is down. It is showing minus 1.4 ampere. Now look here. In node 1 you have 1, 2, 3 elements made. 1, 2, 3 elements. Node 2 also 1, 2, 3 elements. 1, 2, 3. So all the connections we have drawn here in the nodal diagram, all elements are included. Now you are looking, nodes are more projected here. So now we have, so the third step is finished. Now fourth step is assign the node voltages. Now we mark the node voltages here. Node 1 I will mark it as say V1. Node 2 I am marking as say V2. And node 3 I am marking it as V3 or a ground potential. No need to mark. You can take it as a 0 potential, 0 volt. Because all the node voltages we are writing with respect to ground. So that is 0 potential you can write. Now you have 3 nodes here. Now you can have 3 nodes, 2 unknown voltages. You can write 2 unknown equations. So if you are writing the nodal equations over here, you have 2 set of equation you will get with respect to 2 unknown voltages. So the next step is you have to apply KCL to node 1 and node 2. So apply KCL to node 1. Apply KCL to node 1. When we apply KCL to node 1, you have to assume that all the voltages, all the currents are leaving from this node. So this is node 1. Through this resistor element, the current is leaving this node. Through this, also the current is leaving this node, and the source, current source means according to the given direction you have to take. So leaving I am taking as positive, entering I am taking as negative when I am applying the KCL at this node. So for node 1, I have V1, this is 0 potential, so this current is V1 minus 0 by 2 ohm. So I can write it as V1 by 2. Now plus, this one is V1 minus V2 by 5. The current in this branch is V1 minus V2 by 5. So it is V1 minus V2 by 5. and current in this branch, it is entering, so it is minus 3.1 should be equal to 0. On readjusting the equations, like V1 by 2 plus, I can write this as V1 by 5 minus V2 by 5 should be equal to 3.1. So V1 by 2 means I can write it as 0.5 V1. V1 by 5, 1 by 5 means I can write it as 0.2 V1. 1 by 5 is 0.2 V2 is equal to 3.1. So this is 0.5 V1, 0.2 V1, I can write it as 0.7 V1 minus 0.2 V2 should be equal to 3.1. This is my equation number 1. So now the first node is finished. Now to the second node, again I have to apply the Kirchhoff's current law. So for the node 2, when I am applying the KCL, this is node 2, I have to assume that now forget about all this direction, only your mind node 2 should be there. Node 2, assume that all the currents are leaving from node 2 through the resistors, but the current source means as given per the diagram, source given. So now node 2, I can write it as V2 by 1 plus V2 minus V1. Now this current is in this direction, so it is V2 minus V1 by 5. Now this current is also leaving, so I can write as minus 1.4 should be equal to 0. So I can readjust it, this is I can rewrite as V2 plus V2 by 5 minus V1 by 5 is equal to 1.4. After readjusting, I will be getting the final equation as minus 0.2 V1 plus 1.2 V2 is equal to 1.4, or I'll write it in the next page for you. So that equation I can write as V2 plus V2 by 5 minus V1 by 5 is equal to 1.4. So V2 plus 1 by 5 is 0.2 V2, 1 by 5 is 0.2 V1 is equal to 1.4. On readjusting this, I will be getting it as 0.2 V1 plus 1.2 V2 is equal to 1.4. So that is equation number 2. Now you have equation number 1 and equation number 2. You have to calculate V1 and V2. So these two simultaneous equation I am solving by using the matrix method. So I can rewrite it in the matrix form. Coefficient of first equation 0.7 minus 0.2. This is a 0.2 and 1.2. So that into V1 V2 should be equal to 3.1 1.4. Now like previous problems, find delta, that is 0.7 minus 0.2, 0.2 and 1.2. So that we will be getting it as 0.8. Similarly, we will calculate delta 1. Delta 1, replace the first column by 3.1, 1.4 the answer. So it is minus 0.2, 1.2, you are getting it as 1.4. Similarly, we can calculate delta 2. So we will calculate delta 2. So delta 2, replace the second column by this 3.1, so you are getting 1.6, and now V1 is delta 1 by delta, you are getting 5 volt, V2 is delta 2 by delta, you are getting as 1.6 by 0.8, it is 2 volt. Some cut come, but it is in the correct answer form.